In here, we're going to talk about another idea, which is total internal reflection. And we'll do some demonstrations in class tomorrow. Okay? Okay, so let's just say N1 is less than N2. So this is less dense than the bottom one. Okay, so let's just say we're going from air to water. Okay? Now, if I send a ray of light here, okay, it's going to bend. Instead of going straight, it's going to bend down and towards the normal, right? Now, if I increase this angle here, right, okay, it's going to bend even more, okay? Now, so this angle here, the bottom angle, will reach 90 degrees before this angle here, right? So I'm not going to have this idea of total internal reflection. So that can only happen if I'm going from the more dense to less dense medium. So that's a rule. So if I go with an angle like, well, I'm going to do actually a bunch of normal lines here. So if I'm going with a small angle here, okay, I'm going to bend away because the index of refraction here is less. So I'm going to bend away. Instead of continuing straight, I'm going to bend away, right? If I increase this angle, okay, the bending is going to be even more. Okay, this is another case. Now, it will come a point where if I go just at the right angle, okay, it will be no bending. So basically, the refraction will be along the surface of this substance here. So let's just say that's water. So that's what it's going to look like, right? So anything greater than this angle here, that we call the critical angle, will not be able to get out. So it should look like this. And for all these cases, by the way, you always have a reflection, okay? So you have a reflection and a refraction. So if you go past the critical angle, the light just comes right back in and does not get out. And we'll talk about some examples tomorrow. And I'll show you a demonstration, okay? So now, how do we find this critical angle? Well, we're going to follow the rule of refraction. N1 sine theta 1, I guess, or I can call this I, and this is R. Ni sine theta I equals Nr sine theta R. Okay, so Ni sine, so for this critical angle, the angle of refraction is 90. Nr sine of 90. That's when you have total internal reflection, right? Or anything greater than that angle. So if you want to find this critical angle here, you know that sine of 90 is 1. So this is going to be the inverse sine of Nr over Ni. Okay? And it's Nr is less than Ni, so I think I mean this. Nr, Ni. So if Nr is less than, then you should end up with some angle. Now, the critical angle for water, going from water into air, is about 49 degrees. And this is why. So let's just say you have, if this is water and this is air, in order to do this, you would do 1.33 sine of the critical angle equals 1 for air sine of 90. Now, if you do the math here, you should get about 48, 49 degrees. If you do it for diamond, you get about 24 degrees. Okay? So basically what this means that any angle greater than 49 degrees, if the light is coming at an angle greater than 49 degrees, it will just go right back in. It will not get out to the other side. And that's pretty much it.